All right, let's dive right in. Today, we're going to build a smarter AI right here, right now. We're going to pull back the curtain on the architecture that lets a general-purpose AI become a laser-focused expert on your specific documents. It's pretty cool stuff, so let's get started. So here's the big question we're tackling today. You've got a dense 100-page employee handbook, maybe a complicated legal contract, or a pile of research papers. How in the world do you get an AI to give you smart answers about that stuff when it's never even seen it before? Here's our blueprint for how we're going to solve that. First, we'll look at the smart chatbot problem. Then we'll walk through the key steps: ingesting knowledge, creating a smart index, finding the facts, and then crafting the answer. And we'll wrap it all up by showing you why this method, the RAG pipeline, has such a huge accuracy advantage. Okay, let's kick things off with Section 1, the smart chatbot problem. The issue here is actually pretty straightforward. You see, standard AI models have basically read the entire internet, which is amazing, but they haven't read your files, and that's where things get tricky. A typical large language model, an LLM, it's trained on this giant snapshot of the web. But your company's employee handbook? That's not in there. So if you ask it a specific question about, say, your company's vacation policy, it's just going to be stumped. That PDF is a complete blind spot for it. So how do we fix this? Well, we build a pipeline. And that brings us right to our second section, ingesting knowledge. This is step 1, where we feed the AI the raw material it needs to learn from. And here it is, the whole workflow laid out from start to finish. It's a really elegant 5-step process. First, we load the document. Then we chop up the text into smaller pieces, or chunks. After that, we embed and store those chunks. Then, when a question comes in, we retrieve the relevant ones. And finally, we generate the answer. Let's break down each of those stages. So step 1 is super simple. We just need to get the text out of the file. In this case, we're starting with a PDF. We use a handy little tool called PyPDFLoader for this. It does exactly what it sounds like. It just cracks open that PDF and pulls out all the raw text so we can start working with it. And now, moving on to Section 3, this is where things get really interesting. We're creating a smart index. We have to transform that giant wall of text into something an AI can actually search and, understand on a conceptual level. The core idea here is something called vector embedding. It sounds technical, but the concept is beautiful. It's a way to translate words and sentences into a list of numbers, a vector. And here's the key. Text with similar meaning gets turned into a similar list of numbers. It's kind of like creating a super intelligent digital library where all the related ideas are automatically filed right next to each other. And this isn't just theory, it's a real tool doing the work. This is the exact model from our source code that handles this translation. It's called Sentence Transformers / All Mini LM L6v2. This is the engine that reads our text and converts it into those meaningful numbers. Now, you can't just embed a whole 100-page document in one go. That'd be too much. So first, we use a tool called a RecursiveCharacterTextSplitter to break the text into smaller, more manageable chunks. Then, each of those chunks gets turned into a vector and put into a special kind of database called a vector store. In this case, we're using FAISS, which is designed to search through millions of these vectors almost instantly. Okay, so our knowledge is loaded, it's indexed, it's ready to go. Now a user comes along and asks a question. This kicks off Section 4, finding relevant facts. This is the retrieval part of the process. So when a user asks a question, the first thing we do is turn that question into a vector too. Then the system searches the database for the text chunks that have the most similar vectors. This search is controlled by a little number called k. In our pipeline, k is set to 5. This means the system goes and retrieves the top 5 most relevant chunks of text from the original document that are most likely to contain the answer. So, we have the user's question, and we've just found the top 5 most relevant facts from our document. We're on the home stretch now, which brings us to Section 5, crafting the answer. Now this right here might be the most critical piece of the whole puzzle. We don't just ask the language model the user's question. We give it very specific instructions using a prompt template, which you can see right here. We feed it those 5 chunks of text we just retrieved, that's the context, along with the user's original question, and then we give it a direct command. Answer the question using only the context below. This is so important because it forces the AI to ground its answer in the facts we just gave it. And the model that actually carries out this final step, The one that synthesizes all that context and the question into a nice, coherent answer is Google/Flan T5 base. This is the generation part of Retrieval-Augmented Generation. It's the one that writes the final response. So we've now built our entire pipeline, all the way from a PDF to a final answer. But you might be wondering, why go through all this trouble? And that brings us to our final section, the RAG accuracy advantage. It's all about grounding the AI in cold, hard facts. This slide says it all, really. A standard LLM, on the left, can sometimes hallucinate, which is a fancy way of saying it makes things up when it doesn't know the answer. Our RAG pipeline, on the other hand, is grounded in the source material. A standard model's answers can be a total black box. You've no idea where they came from. With RAG, the answer is totally transparent because we can point to the exact pieces of text it used. You see, this technology is a real game changer for how we interact with huge amounts of information. It can turn any library of documents into an expert you can have a conversation with. And that leaves us with one last big question to think about. Now that AI can truly master any text we give it, what kind of knowledge are we going to unlock next?